Hello, biomedical students. So today we can discuss about the bioceramics from Unit 3. This is the continuation of the previous presentation. So hope you have go through the presentation and the YouTube video that I have posted before today's, which is based on the bioceramics. So today we can discuss about another kind of bio-inert bioceramics. So there are different types of bio-inert ceramics: alumina, zirconia, carbon, hydroxyapatite, glasses. So this different bio-inert bioceramics we have discussed in my previous presentation about carbon, detailedly about carbon, what are all its properties, applications, how it is prepared, different types of carbon, everything we have discussed in my previous presentation. So today we can see another two types of bio-inert bioceramics: alumina, that you can call it as aluminum oxide, or zirconia, or also called as zirconia oxide. So first we can see detailedly about alumina and its properties, applications, and disadvantages, how it is prepared, etc. So important features of alumina. So if you see alumina, it is dense, it has high purity. Alumina is used for femur heads applications, and also it is used as a joint components and dental implants because of its important properties such as excellent resistance to corrosion, good biocompatibility, high resistance to wear, and high resistance to fracture. So if you see, the alumina implant is mostly used as a femur head. So what is femur head? I think you have come across this femur head. If you see this diagram, you can understand what is femur head. So this is a thigh bone. So if you see, this is the thigh bone. The highest portion of the thigh bone is called as a femur head. This part, femoral head, that is the highest portion of a thigh bone, where this alumina can be used as an implant for this portion. So that is the important application of alumina and important feature. So if you see this diagram, you can see the different parts of the thigh bone, where these different parts are based on the alumina bio-inert bioceramic implants. So different parts, the first part maybe it is a cortical bone, trabecular bone, third one is a bone cement, this one that we have seen in the previous slide, that is carbon is used as a bone cement, metallic femoral process. So this picture shows the different applications of bio-inert ceramics to be used as a how it is used as an implant in a thigh bone. So this is the X-ray image of a thigh bone. So where you can see clearly the X-ray image shows the picture of a thigh bone. So implant preparation method. So for biomedical applications, alumina is sintered at 1600 to 1800 degrees Celsius. Sintered is nothing but heated. Along with the alumina, some of the additives also used to inhibit the growth of grain. What are all the additives? Here you can see MgO, magnesium oxide, silicon dioxide, and alkaline oxides, calcium oxide. These are all the some of the additives used to inhibit the growth. Inhibit is nothing but to increase the growth. So it is sintered at 1600 to 1800 degrees Celsius, and along with that some additives used. So this picture shows the alumina balls. So this is the alumina balls which is prepared by this heating method. So you finally will get a product as an alumina ball. Then you can further process for its different application. So this is if you see, this slide shows the preparation of alpha alumina. So alpha alumina is one of the crystal type of aluminum oxide. So first pure alumina powder is taken and it is exposed to isostatic pressing. So isostatic pressing is a manufacturing process. So you can clearly see in this diagram the isostatic processing method. So here you have a heating chamber, and inside the heating chamber you pass the argon gas. Here you can pass the argon gas to the heating chamber. At the center part you have a steel chamber. So in the steel chamber you will place alumina powder, and then you will apply the temperature. So that is called isostatic pressing method. It is a manufacturing process. What is the advantage of isostatic pressing? It is used this method. If you prepare the alumina using this method, the pore size is decreased, the pore size of the alumina powder is reduced, and the density is increased. That is the advantage of isostatic pressing. So you have another type of isostatic. Here we use hot isostatic. Cold isostatic is also available. So firing at 1500 degrees Celsius to 1700 degrees Celsius. Finally, the steel chamber where the alumina powder is kept is fired at 1500 degrees Celsius to 1700 degrees Celsius, and we will obtain the alpha alumina in the HCP structure, hexagonal close packed structure. So the strength, fatigue resistance, and fracture toughness of the prepared alumina, obtained alumina, alpha alumina, depends on its grain size and purity. So this is the preparation of alpha alumina method, where finally we will get the product alpha alumina. So sapphire is also another type of crystal structure of aluminum oxide. So sapphire is a natural single crystal of alumina. It can be used to make implants. First, it is prepared by feeding free alumina powders onto the surface of a seeded crystal. So this is the preparation method: feeding free alumina powders onto the surface of a seeded crystal. So how this preparation method works, we can see. So if you see this picture, so this is a crystal where if you see the surface, you can see some small dots. So this is a seed which is grown over the crystal. So this crystal can be any type of crystal, any type of metal. Maybe it is an aluminium, or it may be a zinc, or it may be a cobalt crystal. Any type of crystal, a seed is grown over the crystal. Seed is nothing but as a small catalyst. It can be used as a catalyst to grow another crystal over the surface of this existing crystal. So seed is nothing but it acts as a catalyst. So after growing the seed, suppose if we expose this crystal towards the electric arc or oxyhydrogen flame, that we will pass the alumina gas or alumina powder. When we expose to this crystal at that certain process, finally alumina is fused powder builds up. Fused is nothing but the alumina is grown over the seed, so that is called fused. Fused is nothing but joined or bended. So the alumina will be grown over the surface on the seed, which is grown on the surface of the crystal. That is called sapphire. So that is called as sapphire. So mostly it is used as in dental implants. So this is implant exposure. So implant exposure is nothing but when you implant this alpha alumina or sapphire into the human body, that is psychological media, it will have some effect. That is, a crack will be produced. That is called crack growth. So due to this crack, the strength and fatigue behavior of the implant will be get affected due to the crack growth. So these are one of the disadvantages when you implant. After implantation, this alpha alumina and sapphire suffers with strength and fatigue behavior. So these are all the different physical properties of aluminum oxide bioceramics. If you see physical properties, these are the different physical properties: alumina content, silicon oxide, and nitrogen oxide. This is the additive which is added for the growth: density, average grain size, hardness, bending strength. So these are all the corresponding values, corresponding values for the commercially available implants. So this one is the fixed ISO standard values for the implants to be implanted in the human body. So the value should not exceed the ISO standard. So the alumina content should be greater than 99.7. Additives should be less than 0.02 percentage. Density is 3.98 gram per centimeter cube. 3.6. So this is commercially available material. This is the ISO standard fixed. So mechanical properties of the alumina depends on grain dimensions, that is on percentage of additives. Grain dimensions above 7 micron may cause a decrease in mechanical features, and the allowed grain size will be less than 4 micron, and purity should be 99.7%. So grains is nothing but we have seen clearly what is meant by grain in the first unit. So the 7 micron, it will affect the mechanical property. If it should be in 4 micron, so the property will be very good. So other typical properties is along with this grain size, there is another mechanical properties: surface finish, compressive strength, Young's modulus, fracture toughness, implant strength. So these are also will affect the mechanical properties. So the value should be when compared with the ISO standard, it should not exceed the ISO standard for the better performance: surface finish, compressive strength, Young's modulus, fracture toughness, and implant strength. So different applications. So if we see the applications of alumina, so it is used in orthopedic application, dentistry, and porous alumina. So if we see orthopedic application, it is used in hip and knee joints, tibial plate, femur shaft, shoulders, vertebra, lengthening spacer, and ankle joints and prosthesis. These are all the different applications of alumina, which is in orthopedic applications. Dentistry, it is also find application in dentistry, that is sapphire and sapphire crystal structure. So as well as in a reconstructive maxillofacial surgery to cover bone defects. So if you see maxillofacial surgery, this is a one kind of surgery which is made on the mouth, face and jaws. That is called maxillofacial surgery. This surgery is made only on the face, mouth and the jaws. Finally, porous alumina. Porous is nothing but the implant has a pore in it. So it is used in teeth roots. These are all the different applications of aluminum oxide, that is alumina implant. So this diagram explains the different thigh bone and how the alpha alumina is used. Different parts can the alpha alumina can be used as an implant as this kind of parts: actobular cap, femoral head, femoral stem, unassembled hip joints, total hip joints, and etc. So these are all the different applications. Biocompatibility. So biocompatibility applications, it is used in implants. So if you see, when we implant the alumina, thin fibrous capsule is formed into the inside the human body. So the nature of capsules formed depends on the type of materials used. So if the material is how the implant material may be in a form of solid, perforated type, porous type, and thickness type. So depends on the nature of the implant. Maybe it is a solid, perforated, or porous. The capsule, the fibrous capsule, will get changing. So finally, the tissue compatibility, tissue compatibility is increased when we implant the alumina implant in the human body. Alumina advantages: alumina is not cytotoxic, that is, it is not a toxic to cell. All implants does not show inflammatory or progressive fibrotic reactions. Disadvantages: worn out alumina particles are observed in the interstitium of the lung. So interstitium of the lung, so worn out is nothing but it may be damaged, or in Tamil you can say it is a theimanam. So when you implant, after some days or some years, it will get worn out, or it will get damaged, or in Tamil you can say theimanam. That is called worn out. So it is used in this liver, spleen, and phagocytosis. So hope we can see the zirconia implant in the next presentation. So these are all the importance of alumina. Thank you.